Hi there, and welcome to this lesson. In this lesson, we're doing coordinate geometry, okay? And on the coordinate geometry, we're learning about the angle between two intersecting lines. Okay, and at this point, I'd remind you to set the video to play in 1080p HD. Very important that you do that so you see everything clearly. And you can do that via the settings icon on the bottom right. And if you have any issues at all as the lesson progresses, please feel free to get in touch. Okay, we're always here, we're always available to help, and you can do so via the course dashboard. Okay, and yeah, let's jump right into the lesson. So the angle between two intersecting lines, okay, and what is this all about? Let's find out. So consider the figure below, okay, well, it's the angle between two intersecting lines. It's pretty much self-explanatory, but yeah. So I have my Cartesian plane and I have my two axes, my x and y axis, and I have this line, okay, on my Cartesian plane, and I have this other line, so they're obviously intersecting lines. Okay, and what we're interested in this lesson is this angle, the angle between two intersecting lines. Okay, so what do we know about this angle? All right, let's consider the first line now, and let's consider the angle that the first line makes with the horizontal axis. Okay, and we'll call this angle theta 1. Now let's consider the second line, and similarly the angle this line makes with the horizontal axis we're going to call theta 2. Now if you remember from the past lessons, you know that theta 1 um, has a relationship with the gradient of line 1, and theta 2 has a relationship with the gradient of line 2, but we'll get to all of that, and we're pretty much just trying to express theta as a function of the two gradients. Basically, it's coordinate geometry. That's pretty much what it is about. But then how do we approach this? Let's find out. So something that we know from basic geometry and angle properties is that the external angle, looking at the triangle we formed from the horizontal axis and the two intersecting lines, you can tell that the external angle theta 2 equals the sum of the internal angles theta and theta 1. Okay, and then basically what you then have is you have that theta equals the difference of theta 2 and theta 1, i.e. theta 2 minus theta 1. Okay, now let's find the tangent of these. Okay, so we just apply, since we have that theta equals theta 2 minus theta 1, you can say that tan theta equals tan of theta 2 minus theta 1. Okay, because theta equals theta 2 minus theta 1. Okay, and from complex trigonometry, okay, you can have that tan theta 2 minus theta 1 equals tan theta 2 minus tan theta 1 divided by 1 plus tan theta 2 tan theta 1. Okay, it's a law basically when you have when you ask to find the tan of the difference of two angles, you have the tan of the first angle minus the tan of the second angle divided by 1 plus the product of the the tangents of the two angles basically. And yes, so that's how we arrive at this point. And then you'd remember from when we're talking about gradients that tan theta 2 is m2, the gradient of the line 2, and tan theta 1 is m1, the gradient of the line 1. And I think we can go ahead and do this. Okay, and then if you're looking for the angle between two intersecting lines, you can simply say the angle theta is tan inverse of the difference of the gradients of the two lines divided by 1 plus the product of the gradient of the two lines. And yeah, that is how you find the angle between two intersecting lines. Okay, so something else we need to take note of. All right, and sometimes we have parallel lines. Okay, parallel lines, and we want to establish a relationship here. So for parallel lines, I believe you would agree with me that the angle between two parallel lines is 0 degrees. Okay, there really isn't an angle between an i.e. 0 degrees. But yeah, let's say the angle between two parallel lines is 0 degrees, and i.e. tan theta equals tan 0. Okay, and if you find the tangent of 0, what you end up with is 0. And what this would imply, because we have the tan theta equals m2 minus m1 divided by 1 plus m2 m1, what this would imply is that m2 minus m1 divided by 1 plus m2 m1 equals 0 for two parallel lines. Okay, two parallel lines with gradient m1 and gradient m2. When you solve m2 minus n1 m1 divided by 1 plus m2 m1, it will give you 0. Now if you cross multiplied, basically you would end up with m2 minus m1 equals 0 times 1 plus m2 m1, and basically what you end up with is m2 minus m1 equals 0. Okay, so and this would result in m2 being equal to m1. And if you think about it, okay, basically you have two parallel lines on a Cartesian plane. They pretty much share the same steepness. Okay, basically they follow the same they flow in the same direction, and it should suggest that they have equal gradients. But yeah, that's pretty much how we arrived at that, and this is the condition for parallelism. Okay, very important. If you have two parallel lines on a Cartesian plane, it simply implies that they have equal gradients. Okay, so now let's consider perpendicular lines. Okay, perpendicular lines, and perpendicular lines are lines that the angle between perpendicular lines is 90 degrees. Okay, and basically we have that theta equals 90. Okay, so if we have theta equals 90, we have that tan theta equals tan 90, and tan 90 is infinity. If you put tan 90 in your calculator, it will give you an error. Okay, because tan 90 is infinity. Okay, so how do we apply this to basically what we've been talking about? Now we have the tan theta equals m2 minus m1 divided by 1 plus m2 m1. Okay, and basically we have this for 90 degrees, we have this as infinity. So for perpendicular lines, m2 minus m1, the gradients of the lines m2 minus m1 divided by 1 plus m2 m1 equals infinity. Okay, so what are we going to do with this? Now, here's a condition. The only way you'd ever get the value infinity, okay, the one way we usually get the value infinity in maths is when we divide something by 0. So if you divide any number, let's say 1000 by 0, you would get infinity. If you divide 0.1 by 0, you would arrive at infinity. So what this implies is that our denominator here equals 0, okay, because we're dividing by 1 plus m2 m1, and what this says is that 1 plus m2 m1 equals 0. Okay, and basically what we have is that m2 m1, the product of the two gradients, equals minus 1, and what you have is you have m2 equaling minus 1 divided by m1, and this is the condition for perpendicularity basically. And what this simply means is if you have a line with gradient m1, okay, and you're trying to find the gradient of the line that would be perpendicular to that line, you simply divide minus 1 by the gradient m1, and it will give you the new gradient of the perpendicular line m2. Okay, let's move on. So let's go ahead and solve some examples. Examples here, and we start off with example 1. Okay, and example 1 says find the equation of the line passing through the point minus 3 comma minus 11 and parallel to the line y equals 3x plus 4. Okay, so we have a line, and this line, it passes through the point minus 3 comma minus 11, and it's also parallel to another line with equation y equals 3x plus 4. Okay, so let's go ahead and solve this. Now the first thing we want to do here is basically we have that the gradient of our line y equals 3x plus 4 is 3. Okay, 3x plus 4, mx plus c. M is 3 in this case, and basically we want to find the gradient of our second line, okay, i.e. the line that passes through the point minus 3 comma minus 11, and the gradient of that line, basically we have, since they're parallel lines, we have m2 equaling m1, i.e. m2 equals 3. Okay, so we've established that. Now the next thing we want to do is we have the gradient of the line and we have a point that the line passes through. We can go ahead and work out the equation of the line. We have y equals mx plus c, y equals 3x plus c, because the gradient is 3. Okay, and then we can substitute, we can bring in the values from the points and put them into that equation there, and what you have is y minus 11 equals 3 multiplying x minus 3 plus c, and then I think we can go ahead and solve that out and arrive at a value for c. So we have that c equals minus 2. Okay, and all that's left to do now is to just write out our equation, and our equation, we have m as 3 and c as minus 2. We have y equals 3x minus 2. Let's do another example. Example 2. Now example 2 says find the equation of the line passing through the point 2 comma minus 5 and perpendicular to the line y equals 2x minus 7. Okay, so similarly we have a line y equals 2x minus 7. Okay, and we have another line that's perpendicular to this line, okay, and also passes through the point 2 comma minus 5, and we've been asked to find the equation of this second line. So the first thing we do here is we have that m1 from the line y equals 2x minus 7 is 2. Okay, so m, the gradient there is 2. All right, and then we want to find the second gradient. The gradient of the perpendicular line m2 would equal minus 1 divided by m1, i.e. minus 1 divided by 2, because m1 is 2, and what we end up with is we have minus 1 over 2. So the gradient of the second line is minus 1 over 2. Now we have the gradient and we have a point that the line passes through, and I believe we can go ahead and solve for the equation of this line. So step 2, we have y equals mx plus c, i.e. y equals minus x over 2 plus c. Okay, and then we can substitute those points into the formula, and we have minus 5 equals minus 2 over 2 plus c. We have minus 5 equals minus 1 plus c, and when we solve for c, we end up with c as minus 4. Okay, and I believe we can go on and say y equals minus x over 2 minus 4. Okay, but then there's one thing we can do. We can multiply the whole equation by 2, and we have that 2y, just to make it look better. Basically we have 2y equals minus x minus 8, and that is how you solve for the equation of a line that's perpendicular to another line. It's actually fairly simple. Okay, it's no different from what we learned 2 lessons ago, but then all you need to know is you need to know the condition for parallelism, and you need to know the condition for perpendicularity, and once you know that, i.e. m2 equals m1 and m2 equals minus 1 over m1 respectively. So I think we can do another example. Okay, let's go ahead and do that. So example 3, and example 3 says find the acute angle between the lines y equals 3x plus 4 and y equals 2x minus 1. Okay, so This basically, we've been asked to find the angle between two lines, and what we need to do here is we need to apply this formula. Okay, theta equals tan inverse of m2 minus m1 divided by 1 plus m2 m1, because we have the gradients of the gradients of the two lines basically, and we have the gradients as 3 and 2. Okay, so now that we have the formula, we need to identify our parameters, i.e. m2 and m1. But there's something very interesting here. Which line would you say is m2? And which line would you say is line 2? And which line would you say is line 1? Because it doesn't follow the way it's written down in the question. You can't go ahead and say y equals 3x plus 4 is line 1. No, you don't do that. But then how do you know which line is line 1 and which line is line 2? What we do here, if we're looking to get an acute angle, okay, we usually assume that the line, the steeper line, okay, is m2. Okay, we usually, because anytime you trying to get an acute angle, i.e. an angle between 0 and 90 degrees, your the tan of that angle has to be positive. Okay, so you need to work m2 minus m1 divided by 1 plus m2 m1 to give you a positive value. Okay, and the way you do that is making the line, because if you make the smaller value m2, you would end up with a negative numerator, which will usually result in a negative overall answer. Okay, so what you do here is m2 in this case would be the larger gradient, which is 3. So we have that m2 is 3 and we have that m1 is 2. Okay, and I believe now we can go ahead and substitute those values into our formula, and what we have is theta equals tan inverse of 1 over 7, and theta equals 0.1429. okay, and what we have is we have theta as 8.13 degrees. Okay, and yeah, that is the acute angle between the lines y equals 3x plus 4 and y equals 2x minus 1. Okay, and yeah, that would be it for this lesson. Okay, the angle between two intersecting lines, and yeah, bye for now.